Welcome to JEE NEET video lecture of chapter 3 motion in a straight line, and topic is distance and displacement. Today we will discuss example number 6. Wheel of the radius 1 meter. Wheel of radius is given as 1 meter, so value of r is equals to 1 meter, rolls forward half a revolution on a horizontal ground. So it rolls forward half a revolution on a horizontal ground. We are talking about only half revolution on the horizontal ground. The magnitude of the displacement of the point, magnitude of the displacement. We need to find the magnitude of the displacement of the point of the wheel initially in contact with the ground. So we want to find the displacement of the point of the wheel initially in contact with ground. So whatever the point is connected at the ground initially, right? We want to calculate the displacement of that point after half of the revolution. After half of the revolution. To visualize this problem, I will show you a small animation. Right? Visualize that first, and then we are coming back to this example because visualization is more important. What is the rolling of a wheel with the radius 1 meter and the point which is initially in contact with ground, and we are going to find the displacement of that point. Okay, now visualize this problem. This is a half of the revolution, right? It started from this point and moved to, I'm sorry, looking at the revolution again. If you look at the revolution of the wheel very carefully, right? The starting point was, I'm just showing you the starting point, and starting point was this one. This was the starting point, right? And after the revolution, sorry, this was the starting point, right? And after the revolution, half revolution, this point com- comes to this point, right? So this point was initially touching to the ground. After revolution, that point, say this is a point A, it goes to here at the top of the wheel, right? And this point is opposite point of A on the diameter at point B. And because its radius is r as 1 meter, this distance is half of the circle, and half of the circle is pi r. R is 1 meter, so it's pi into 1 meter. So AB distance is 1 meter, and of course BA distance is 2r, and 2r is equals to 2 into 1 meter because r is 1 meter. Okay, so this is how a point which is initially with the contact, sorry, initially at the contact with the ground, right? With the half of the revolution, that a point reaches to the top of the circle, top of the wheel, and now this is the displacement. This is the displacement. Initial position I, final position F. So A to A dash, you can say this point as the A dash point, and A to A dash is the displacement. Okay, so now going back to the original problem. In the original problem, the figure will be something like this. So A point initially touching at the ground, right? The wheel initially, the point of the wheel initially in the contact with the ground, right? That's the A point, and after the rotation, this revolution on the horizontal surface, that point reaches to the A dash point, right? And this distance A to B distance is pi r, which is a half of the circle, and AB is 2r, right? This is the initial position and this is the final position. So the point A, displacement of the point A, we can easily find using the Pythagoras law, and that is the distance A dash is equals to under root, applying a Pythagoras law, under root pi r whole square, pi r whole square plus 2r whole square, 2r whole square. The value of r is 1 meter. So at the r, we can substitute the value 1 meter. It becomes pi square plus 2 square is 4. Right? So that is A dash. So displacement of the point of the wheel initially in contact with ground is pi square plus under root pi square plus 4. So answer C, under root pi square plus 4. C option is our answer. Right. So if you visualize it properly, it is very easy to find a displacement. Understand the problem and then visualize the problem and then apply the formula.